All right, welcome everybody. Thanks for joining us today to have a little chat about software in the additive manufacturing space. It looks like we still have some people joining, but we're going to go ahead and get us kicked off here. So my name is Robert Byer. I'm the product marketing manager at Techsoft 3D for our Hoops toolkits. But I'm mainly here today to introduce my colleague, Jonathan Giroir, who's going to be talking us through building a software application for additive manufacturing. So Jonathan's been with Techsoft for over 12 years now, and in the 3D visualization space for 20 years now. So you're in good hands, and with that, I'll let Jonathan take it away.
All right, thank you, Rob, so much for that introduction, and thanks everyone for joining us today. Kind of a different experience doing a virtual conference, and obviously everybody's trying to get used to doing things new, a new way. So thanks so much for tuning in here, and we'll be talking about building software applications for additive manufacturing, and hopefully you get a chance to learn a few things. So here at Techsoft, that's the company we work for. We work with over 600 different software companies, software hardware companies in engineering and manufacturing, and have an opportunity to see how they're using different tools to do some really cool things when it comes to innovation. And we're so grateful to be able to work with those companies and bring them technology and be able to see what they do to make the world a better place. And what I hope to do is bring some of that innovation back and show you what's going on in this world of manufacturing, particularly when it comes to additive manufacturing, and how different companies are using components, software toolkits to build the next generation of engineering toolkits. So if you just think for a moment, where is innovation happening when it comes to additive manufacturing? If we were to talk about like different pillars in this space, where do we see that happening? Well, obviously, the first could be hardware, right? So we really have seen a renaissance in the last decade or so in terms of the machinery being used, in terms of size and efficiency and accuracy. That really is an opportunity for innovation. Another place is when it comes to materials. So material science and what we're able to print with and how we print it. That too is adding to the efficiency and the variability of the different applications that we have when it comes to being able to create 3D parts using 3D printing. And then the last part is software, and that's what I want to talk to you about today. And that's my background is software development, and what are people doing in this world of software to drive these printers and to print using this material that's innovative and new and is able to bring to market and to our users new techniques that they might not have been able to apply in the past, especially when it comes to traditional manufacturing. So what we're really going to talk about are those software components. So not end user software. So we're not going to be showing NetFab or Materialize, but really the building blocks for you to then go take those building blocks and make the next generation of software for additive manufacturing. So I'm gonna put up a real quick poll here in the webinar, and just I'm curious of who in your organization either develop or plan to develop software. So I'm just curious, this is kind of like a high level conversation. So we're not going to be looking at code unless you absolutely want to, but I'm just curious of who's in this software field, and kind of who might be interested in this, and kind of my fellow software developers. That's good, because our target audience, it looks like 82% are doing software. So that's really good. So we're going to be talking about this component technology and these different building blocks. So let's take those building blocks and look at a workflow for manufacturing, which is which is very similar to a workflow for additive manufacturing. There are differences, but the way in which we move data through and the different building blocks are really very similar. So it all starts with your CAD files over here on the left, importing it into your application. And you would think that would be an easy task, but you'll kind of see why I want to highlight that. And that's very important, that import section of your application. Once you have that, it might be sufficient just to export it to your 3D printer. So bring in a file and then push it out in a form that the 3D printer can interpret. However, many times there's a lot of additional editing that needs to be done, and much of that is being driven by the user. It is true that people are trying to go to lights out manufacturing, where you bring your data in, it automatically gets healed and analyzed, sliced, changed in such a way that it can be printed. But right now there has to be user intervention. So there's this edit workflow where you edit and you view and you change and you add support structures or lattice structures, or you thicken the walls. So there's some editing being done to that file to prepare it for printing. Additionally, on top of that, and we really want to break this out, is that that there's a step of analyzation. I want to talk about that as well, particularly when it comes to manufacturing. There's always or many times there's a step where we analyze the part, and is it manufacturable? How does it behave out in the real world? And so we'll be talking about that as well, and how it applies to 3D printing. That's kind of something a little bit new as well. But let's focus in on just that CAD import for a minute. We'll be looking at each of these different components. So if we look at STL files, which we all use, there's a ton of them out there, and we're just for historical reasons, we're used to reading those and using them for 3D printing. But really, there's some inherent problems with STLs that we want to draw attention to, and actually say, because of those problems, STL is dead. So a couple of reasons. First of all, STL is a polygon, tessellated, primarily triangle file format. So it's just a group of triangles. Depending on how that set of triangles is created from the original CAD surface, those CAD surfaces, they aren't most times a set of triangles. It's a set of surfaces that are described mathematically. Your holes and your rounded surfaces are round. There's cylinders, and they're tori, and they're cones. They are planes, but all of those surfaces, they need to go through a step of tessellation to create the STL file, and a level of accuracy is lost in that tessellation step. As you see here, the tessellation doesn't fit on the topology. That may be a problem when you go to manufacture the part. Our machines are getting much more accurate in what we can actually create, and the accuracy of that tessellation might not be to the accuracy of our machine or what we need to build to. If we have two parts that we're producing that need to mate to one another within a certain tolerance, all of a sudden maybe that tessellation isn't adequate for us. Additionally, these STL files, that whole format was designed decades ago, and it doesn't really conform to the modern use of assembly structure, material structure, and other design intent for these different parts and assemblies. And so it's just a collection of triangles, and it can't really embody additional information, especially here, you see here on the right, manufacturing information. So dimensions and the tolerances that go along with that, that's captured in the original CAD system, but is lost when saving to STL. And that can be very useful in saying, can I even manufacture this part to spec? So in the end, what we'll say is rest in peace, STL. Well, what do we do then? What's better? Well, what's better is going to the original CAD file. So here's a quick video of GrabCAD print. And we're going to load both an STL file for some earbuds and their containing case, as well as the SolidWorks assembly. So using CAD import, we do import the STL file, that collection of triangles, as well as we load directly in. There's no export step to STL, but we load directly in the assembly the SolidWorks assembly. And you can see each of those individual pieces in the assembly disassembled and reassembled. We're also able to assign specific materials to each of those individual parts. So the materials that existed in the SolidWorks assembly and the SolidWorks part files, those are brought in too. Now we can assign a material to the STL file, but because it's just one collection of triangles, everything gets changed to that particular material, that particular color material that we're going to print with. However, this assembly structure for the full CAD assembly, we're able to maintain their difference, the translucency, the color, and the material that we're printing in. Additionally, we can instance that and select individual parts now because they exist in this realm as a specific part. We're able to change the material for that specifically. And right here within our view environment, we're able to test out different configurations as well. So whereas at one point we only needed to worry about STL files, and that was those problems with an STL file, they were mitigated with 3MF files, but there's just so much more rich data that we want to get access to. So we did a great job printing STL files. The 3MF files fixed some of those problems where you could have instancing materials and additional design intent embedded, but you're still not getting as close to the original CAD data as you can. Not only that, but there's a lot of data from different vendors out there. So one of the things that is important is finding a way to get access to all of that, no matter where your data is coming from. If it's coming from Pro Engineer or Autodesk Inventor or any of the Siemens products or any of the standards, you want a way to bring all that data together and have one interface. And most of the CAD access tools out there, they do that. They have a many-to-one mapping. So all you need to do is be able to interpret one set of data structures and not maintain connections to all of these different file formats. So that's the good news, is that CAD import, you can import STL files and then many times all of these additional file formats, 3D file formats, and get the richness. You get access to the richness of the data that is inside those CAD files and make intelligent decisions about how you're going to print given that. So you get assembly structure, you get BREP or boundary representation. So that's the mathematical surface of the mathematical description of the surfaces. You get your product manufacturing information. So what are the dimensioning and tolerances? That's really important. If you have a quoting system, let's say people are uploading files to an online system and you want to create an automated quote to them, that product manufacturing information is going to be important because you're going to know what machine is going to be able to hit those tolerances, or if you can't do it at all, and that's going to affect the cost that you quote. Then features. So in addition to dimensioning and tolerances, we actually can tell you that these are holes or these are blends, these are slots. There's kind of traditional manufacturing speak, but sometimes you may want to de-feature and simplify the part. Maybe those holes aren't important, and so you can identify those features because they exist in the original CAD file and be able to react to that. And then additional metadata. So particularly what's the material, not just the color, but what is this being made out of and what are the properties of that? So many times that information exists in these CAD files as well. Well, I have some bad news. This is great. Getting access to all this different CAD data, this is great. But the bad news is there's still a ton of STL data and mesh data out there. So many of these libraries that we're still working with and the files we're getting are STL files. Not only that, but we see a tremendous amount of mesh data coming from the manufacturing world. It could be from reverse engineering where there's a point scan of a part. We need to mesh that, and we need to heal that. We need to denoise it. There's terrestrial scanning, so not just scanning of parts, but scanning of massive models, like architectural models, and we need to be able to work with that mesh data as well. So for that reason, a whole class of tools have been created that are built around taking that STL, that mesh data, that point cloud data, and preparing it in a way that we can then go off and print it. So much of this data has holes. The triangles aren't oriented correctly. They're non-manifold, meaning triangles are sharing edges, like 3 triangles are sharing an edge. Like, how can you manufacture that? The surfaces could be thin. They need to be thickened. You might need to remesh because it's not as accurate, or a particular area needs to be sharpened. So there's all these what we call polygonal modeling tools out there. And for that reason, 5 points for anybody who can put into the chat what movie this quote is from. STL, well, not STL, but I'm not dead yet. So STL is still here. The movie didn't talk about STL, but it did talk about a plague. Oh, maybe that's not the best time to talk about that. But 5 points for anybody who, it's one of my favorite movies. But STL is still here, so we have to be able to work with it. And here's a quick video of one of these toolkits working with an STL mesh file. So this is a door frame for a car, I believe, and it has no thickness. We want to manufacture this, but it has no thickness. So you zoom in there and you see that it has no thickness. We want to thicken it, and so we're gonna come up here and we're going to create an offset. So this is using a mesh modeling toolkit called Polygonica. We'll talk about that in a little bit. It's a product we resell from MachineWorks. We fast forwarded about 50 seconds there, so it does take a little while. It's a very complicated file. It has about 500,000 triangles. But now this part is solid. We thickened it by 1 millimeter. It's something that can be printed now. You notice the number of triangles has increased, and it was done with a spherical offset. So if we go back and zoom in, you can see that it does have a thickness, and in that one feature, that kind of fold over, let's see if we can go and take a look at that as well, and kind of zoom in, you'll get a good shot there. So here now we've altered our mesh. You also saw at the very beginning, the toolkit reported that, hey, this is an open surface. So all those green lines, those are triangles that don't share their edges with another triangle, so it can't be printed. There's this giant holes, and in fact, the whole surface itself isn't closed. And so there's a whole process. Many times data coming from point clouds or even our STL files, they have holes in them as well. And it really becomes an issue. So those mesh modeling toolkits certainly solve those problems. Well, modeling continued. Modeling has been around for decades. In fact, in traditional manufacturing with CAD-CAM solutions like NX and SolidWorks here, they're leveraging an underlying mathematical engine that does solid modeling. So they're in the space of extruding and making holes and doing booleans and rounding surfaces. And there's a whole class of tools around solid modeling, which has been hardened and has been out for a long time and is well established. That's great. And we see more and more people wanting to get closer and closer to that CAD data. So if you have your CAD data, we showed you the workflow, CAD data coming in, instead of as STL, you would use these solid modeling toolkits to actually edit the CAD model and prepare it for printing. And that's what CAM solutions did. That's why CAM isn't referred to as CAM, it's referred to as CADCAM, because within these CAM, these traditional manufacturing solutions, there's a bit of editing, a bit of CAD kind of embedded within the system that allows you to edit the CAD file ever so slightly so that it can be manufactured. Because many times when a machinist gets the part, they actually can't manufacture it. So there's errors in it, just like that there's errors in files for 3D printing. Now, what we're seeing though is not just 3D printing solutions using solid modeling to edit their CAD files natively. We're also seeing polygonal modeling being used, because data is coming in that's not just BREP or boundary representation CAD data. We also see mesh data being combined many times within some of the same files, or we're trying to operate on mesh data and solid data, bring them together in the same assembly. So there's really this overlap, and there's been a push in this space to create tools that work between both of these. So both solid modeling working on the mathematical surfaces, polygonal modeling working on the triangulated surfaces, and then bringing them together into something called convergent modeling or hybrid modeling. And this is really an exciting area that a lot of innovation is being done in right now. So we got through our data import. We got through some of our editing, so hole filling and adding of supports and adding of lattice structures and thickening and remeshing. So now we also want to make sure that we support viewing it. And these applications can exist on multiple different types of platforms. So it could be web, could be mobile, it could be desktop, it could be Linux, could be Mac OS X, could be Windows. And so you want to make sure that you kind of have all of your bases covered here, and you're able to display text, not just your geometry, but you're able to display that text using a text engine. You're able to display point clouds. We see that here with shading. How do you shade a point cloud? There's all these different algorithms for doing that. You're able to be able to display both tessellated data and surface data and kind of mix between those two. Richard answered my question about the movie quote. Sorry for a diversion. Close. It was Monty Python, but it's not Life of Brian. So that's really close. All right. So what else we got here? Yeah. So you want to make sure you're using your graphics to the full, and it's connected. That's the thing is you're not just using DirectX or OpenGL, but it's connected to your data import and it's bridged to your modeler. And so that's another thing to really consider is when you choose a component for visualizing your data, that it easily brings your engineering data in and it works within that ecosystem. And then the last part we want to talk about is relatively new to additive manufacturing. Many times we were just happy to print, and if it worked, that's great. If it crumbled, well, we'll go back to the drawing board and redesign it. Some of the first things we did were figure out what's the percentage of shrinkage when we manufacture a part. But now we're seeing within that workflow a whole step or suite of analysis tools that allow you to say, how does this behave under heat? How does it behave under pressure? What's our thin wall thickness at right now, and does it need to be changed? If I'm sintering and it does change from when I'm building it on my platform and when it's done being created, it's gonna have a certain amount of deformation. Like, what are the different things that I'm worried about, and I can add to my manufacturing kind of simulation process so that I only have to print this once, because many of these parts, especially for production, these metal parts, they are expensive. We don't want to have waste, and so that really does affect our time and our bottom line. So many times there is an analysis step where you work on design, you work on test, and you work on tune. So how can I make this more efficient? So many times with generative design, we can alter the way in which this model is actually configured to use less material, so it can be built cheaper, yet still have some of the same properties. So a lot is there in this analysis step. So remember our manufacturing workflows and our different big blocks. So you need many times all of these in one way or another. You don't need analysis all the time. You don't need a solid modeler, but it's out there and you need to know that it's available to you if you're going to be going in that direction. Well, like I mentioned at Techsoft, we have a set of different tools. So for CAD import, we have Hoops Exchange, and that brings in your 30 plus different CAD file formats. For visualization, we have Hoops Visualize and Hoops Communicator, and we just added a new product to that suite called Ctron for visualizing analysis results. And then for this analysis and edit, kind of in this space, we have Polygonica. We showed that to you already. We'll show you something real briefly in a minute here. But we also have Parasolid, which is the industry standard in solid modeling, and a connection between the two of those. I know Polygonica has been working on those. So these are like the big blocks and kind of how our products, we call the Techsoft products or Hoops products. That's our brand name. Company name is Techsoft 3D. Our product line is Hoops. We resell Polygonica and Parasolid. You can go to MachineWorks and Siemens to get those, or you can work with us. We're happy to do that with you. But they are experts in their field of polygonal modeling and solid modeling. So we leave that heavy lifting to them and just provide the integrations and expertise. So let's take another quick look at just a engineering application. So this is a demo application, and a call to action actually is if you'd like a copy of this, I can provide that to you. It's for like a 30-day runtime, but we bring in a CAD file. So this is a Pro Engineer file. It has some errors. The tessellation of that file has some errors. We also have our tessellation. So I just wanted to show you a tessellation. We have triangles that are intersecting with one another, and holes. So the red ones are triangles intersecting, the holes are green. So using Polygonica, we healed that. Hoops Exchange allowed me to go in and bring that in. Hoops Visualize is visualizing this for desktop. Then we can simplify it using Polygonica. So if this was a massive point cloud, we could simplify that by a certain percent. We can hollow it out. So we remove the interior. We can clip to a lattice structure. And then I think, yeah, so we want to show here using Hoops Visualize, we have engineering tools for visualization, like a cutting plane to show that that's now hollowed out. If I wanted to, I could add a lattice structure or clip to one, but here I'm just going to do slices. I'm going to create my slices and then I can push that out to print. So I can print from those slices. So over 600 different independent software companies are using our tools. Some of the biggest names in 3D printing and additive manufacturing, like 3D Systems and Stratasys, are using tools from us or from MachineWorks, Polygonica. And these companies are reusing component technology because they then take their intellectual property and put it on top of that and use that. So is an opportunity for any questions. I think we have about 5 minutes. I'm certainly happy to talk about other questions that you may have offline. So I also have some contact information here. But yeah, here's an opportunity to ask questions.
We had one question come in earlier as just if we're going to be able to share this recording of the meeting. So for anyone who came in late or would like to review it, yes, we plan to share the recording with everyone who attended, and we'll make sure it's available for everyone.
Yeah, great. Thanks. Thanks, Rob, for that. Somebody has raised their hand. I'll just allow Stefan to talk. If you have a question, Stefan, you can unmute yourself if you don't want to put it in the chat. I think I allowed you to do that, so you can unmute yourself, Stefan, if you want. Maybe you just raised your hand by mistake. Robert, any questions? Oh yeah, sorry. Okay, that's fine.
Let's see. That's all right, Stefan, no worries there. Yeah, Jonathan, so I got some questions for you here. You know, how would we support a web-based manufacturing portal using Hoops toolkits?
Yeah, so I did kind of show you our different tools. So one of them is called Hoops Communicator, and we do see a lot of new software development going to the cloud and web. So our Hoops Communicator tool and our Hoops web platform sits on the server. It has a server component that allows you to load in CAD files, and it also has a client component. It's a thin client. You don't have to install anything. Sits in your web browser. Supports all of your modern browsers. So that's called the Hoops web platform, and it has some components. It has other Hoops components. Hoops Exchange for reading CAD data. Hoops Communicator for viewing it. We also have a demo on our lab site that shows actually, I believe that working, where you can upload a CAD file, and I might even be able to show that. You can upload a CAD file, and then you can heal it, very similar to the workflow that I showed with the desktop application using Hoops Visualize. So let's see if I can get this and use Polygonica. So this has Polygonica. So I think, can you see that, Robert, with me?
Yep.
Yeah.
Yep,
So let's,
see that.
Since we got a few minutes, and that was a good question, and I like demoing stuff. It's also kind of dangerous this is demo. This isn't a production product, but let's look at some data, and let's look at let's just look at some STL. So I know I have like some STL files here. And let's look at maybe this data set. It's about 50,000 triangles. So what it's doing is it's loading that STL file up on the server. Yeah. Using Hoops Exchange, it then takes Polygonica and analyzes it. So Polygonica tells us it's not closed, it's not manifold, it has intersections, so it's got some issues. So you have some intersecting triangles here. You have some holes. So it kind of look on the inside. We don't draw the back faces of those triangles. We got to fix these. And so using Polygonica, we can send up message to the server. We can say heal that. So it goes off to Polygonica, brings down the next model. Now it's closed. It's manifold. Has no intersections. It's solid. We can do other things like, let's say, simplifying it. We're at 50,000 faces. We can simplify it, and now we have 25,000 faces. We can hollow it out by an offset, whatever we want that to be. So just an example of how you can do that. We see so many engineering applications going to the cloud now. We do see a lot of that.
And Jonathan, that's on Labs.
I'm not sure if it's on Labs, but you can go to cloud.techsoft3d.com and you'll find a version of that.
Great, thanks for showing that. So we had another question come in regarding our licensing model, which is complex to get into over our webinar here. What I would do is encourage you to reach out to one of our partner development representatives who can actually kind of fine tune what you're looking to do or looking to accomplish and walk you through that in more detail. And we have a handful of people here on the Formnext platform that you can reach out to. So we have Maria and Oliver who are available, as well as Andres. So if you're interested in diving in a bit more about the technology, I would encourage you to reach out directly to them, and they could provide a solid answer for you.
Yeah, so I'm not a sales guy. I can't help you with that, but I know there's a component of kind of a relationship, ongoing fee, and then kind of a shared revenue model. But these are your key people here. Mary and Oliver, I know, have a number of meetings set up with you. Reach out to them, and that's important here. So on Formnext Connect, it might be, I found it, I needed to bookmark this, basically. I had to bookmark this page to find it, but this matchmaking domain allows you to connect with Maria, Oliver, and Andreas. Here's their email addresses as well, and we can talk about not just what our terms and conditions are, but we also have a 60-day free evaluation of our software, and you can go here to techsoft3d.com and get access to that. You can sign up for an evaluation and get your hands dirty with the code and implement it within your tech stack. And we pair you with one of our software developers to make sure your technical questions are answered and it's good technical fit. So that's part of our process as well. So I have the website up there, techsoft3d.com. So you can also reach out to us that way. Any other questions?
Since we have just a bit more time and we have our pal Richard on the line from MachineWorks Polygonica. Richard, I'm going to throw a question your way if that's all right. And it goes back to working in the cloud. And how does Polygonica have partners and customers on the cloud for your application?
Hello, everyone. Can you hear me?
Yeah. Yep.
Yep. Okay, good. Yeah. Yeah. So Polygonica is a library written in C, but it's available on Linux. It's available on OS X and obviously Windows. And so I guess perhaps we're not experts in the cloud ourselves, but we have quite a number of customers who are actually deploying Polygonica in the cloud. The majority of them are sort of cloud-based auto quoting type applications, so similar to what Jonathan showed, where you can upload a model and Polygonica will fix it for you, analyze wall thickness, all that kind of stuff, give you some physical properties or give the application some physical properties of the model, and then you can make various calculations about the quoting, and it does all of that automatically. There's no need for any user intervention. So that's that's a fairly common application of Polygonica in the cloud. But we also have some customers who are doing some pretty advanced stuff, more in the areas of, you know, fairly advanced CAE type, you know, analysis and that sort of stuff for additive manufacturing. The sad thing is we're not allowed to name any of these companies, so they all, I guess they feel that they have a competitive advantage in not telling people that they're using Polygonica, so we aren't allowed to use them for marketing. But yeah, it's definitely well used in that environment.
Great, thanks.
Great.
We roped you in there, Richard.
Yeah, no worries. I was busy Googling Monty Python.
we had you on the line, so I figured I'd make use of it.
Yeah.
Well, guys, that looks like it's it for questions. We're a bit running out of time here. I have been reminded that this presentation will also be available on the Formnext platform itself. So we'll reach out directly with a recording, but it'll also be living on the Formnext platform until Formnext shuts down. So I think it's to the end of the year, really. So it will exist there for you.
Great. Well, thank you everyone for your time today, and wherever you're calling in from, be safe, be well.